Hello learners, welcome back to my YouTube channel Learn with Swagat. So today's topic is discussing about different criteria for selecting CPU scheduling algorithms. So before getting into the lecture, if you are new for this channel, please do subscribe and hit the bell icon to get the notifications regarding latest videos of the channel. So let's start today's discussion. Now, as you know that there are different criteria exist for selecting different scheduling algorithms. So let us see today that what are those different criteria and what is the reason behind taking these, what is the reason behind these parameters to take as a criteria for selecting the CPU scheduling algorithms. So let's start with a simple example. So suppose I am a user of an operating system. Now being a user, I have started a program and given to the CPU for its execution. Now what will be my demand? My demand will be obviously that whenever I initiated a program, it should be immediately executed by the CPU. But it might not be the case always, because CPU, whenever I have initiated a program, the CPU might be busy in attending other programs as well, because it is a it is running in a multi-programming environment. So therefore it is not expected that whenever I am scheduling, whenever I am initiating a program and given to the CPU for its execution, immediately it will execute it. It might not be executing it immediately, but it will be executing it maybe after some time. So therefore my expectation should be that whenever I initiated a program, it should be either executed by the CPU immediately, or at least if the CPU is busy, it should be scheduled in the CPU as soon as possible. Okay, so there are two terms coming in this scenario. First one is waiting time and second one is turnaround time. So let us see what are the significance of these two items. So if I submit a job or task, say at time t0, suppose I have submitted a task to the computer system at a time t0. Okay, and technically if I'll tell it, then it means it is the time at which I am putting my job into the ready queue. That means my job is ready for execution, but at that time instant it might not be getting executed by the CPU, because CPU might be busy in executing other programs. Let's say at another time instant ti, it is actually getting executed inside the CPU. Okay, that means at time t0 instant of time, I am submitting the job or the process or the program to the CPU, that is the computer. Okay, not the exactly CPU, I am submitting it to the computer, and the process is getting executed within the CPU at time ti. Then how much I am waiting? See, at t0 I am submitting the job, at ti it is getting executed by the processor. So obviously the time which I am waiting is ti minus t0. So this is basically the waiting time. Okay, now as you have seen that at time t0 I have given the job, that is I have submitted at time t0 for the to the computer system. At a time ti it gets executed in the CPU, and obviously when it get executed it will take some time, and after few time it will produces the output. So let that same job produces the output at time tp. Okay, so now see there are 3 times. At t0 I am submitting the job, at ti it gets executed inside the CPU, at tp it finishes its execution and produces the result. So now this tp minus t0 is called turnaround time. That means it is the time between the output of the process to the time when it was submitted into the system. That is called turnaround time. Now these two things are important from the scheduling criteria point of view. Why? You see, as a user, if I am submitting a job for the computers to the computer system, so obviously I always want that my process or my job must be executed by the CPU immediately, but it is not practically possible because many processes might be running inside the CPU. So at least my demand should be that waiting time should be minimum, because I don't want to wait. As soon as I give it, so the CPU try to execute it as soon as possible. So therefore I will always want that how waiting time will be minimum, and similarly the turnaround time also be minimum. Okay, now let's take some more example to understand these things better. Let we have 4 jobs. Okay, J1, J2, J3, J4. These are the 4 jobs I have, and let's say for J1 the time is 15 unit. That means it takes 15 unit of time for its execution. Similarly, J2 takes 8 unit of time, J3 takes 10 unit of time, and J4 takes 3 unit of time. Let us assume that this is the order in which they are submitted to the computer system. That means first J1 arrives, then J2 arrives, then J3 arrives, and then J4 arrives, and these are their corresponding execution time. Means this much time they need for their execution in the CPU. Now I will say some technical technical terms later on, that why means what is the significance of this example, but for the simplicity, usually what operating system can do is it can actually execute J1 first, because see, as J1 arrived first and before it there was no job earlier, so obviously if J1 arrived first and there is no other jobs in the system by that time, so let J1 gets executed inside the CPU. Then in that case the sequence of job which are getting executed inside the CPU will be something like this. J1 takes 15 unit of time, then J2 gets executed up to 8 unit of time, then J3 gets executed, because this is the, we are assuming that this is the order in which they arrive. Okay, then J3 executed for 10 unit of time, and at last J4 executed for 3 unit of time. So this is J4, this is J3, this is J2, and this is J1. Okay, that means if we take this point as a reference, okay, and we are saying that this point is 0, then J1 started at this point and ended this point. Ended in the sense J1 finished its execution by this time. Okay, now let us see how much, because this waiting time is a big deal in this scheduling criteria. So let us just see that waiting time first. Now let's see what is the waiting time for each of the job. Let's calculate waiting time for J1. So what will be the waiting time for J1 here? Now see, as soon as J1 arrived, it gets scheduled by the CPU. That means it gets executed inside the CPU, and before that there was no job. So the waiting time for J1 will be completely 0. Now what is the waiting time for J2? Now waiting time for J2 will be 15. Why? The reason is, for any job, whenever you are calculating the waiting time of a particular job, it depends on how many jobs previous to it gets executed, how much time. Okay, that means for J2, if you want to calculate the waiting time for J2, then you have to see that in the timeline before J2, how many such processes gets executed previously and how much time they have executed, because it is the only time up to which J2 is waiting. Okay, so for J2 the waiting time is 15. Similarly for J3 the waiting time is 8 plus 15, that is 23. Similarly for J4 the waiting time is 10 plus 8 plus 15, that is 33. So now if you calculate the average waiting time for all of them, then it will be 33 plus 23 plus 15 plus 0 divided by 4. So somehow you will get it is 17.75. So this is the average waiting time for this sort of approach. Okay, now let's change the order of the execution. That means what I am saying is, let the job come in any order, because I don't have any control on how they arrive in the system, because it is ultimately it is generated by the users. It is initiated by the users, because if you have say for a particular system they have 10 users, so any user might initiate the programs at any point of time. So the arrival order depends on the initiation of the programs by the user. Okay, so I don't have any control on it, but what I can do is let the jobs arrive in any order, whatever is possible, but we keep them in some kind of queue. Okay, some sort of queue, we'll put all of them in some sort of queue, and from that we decide that what to pick up and give it to the CPU, because that is in our control. Arrival of jobs and creation of jobs is not in our control, because users initiated it. Okay, but which process we will be scheduling in the CPU, that depends on us. Okay, so what I can do is, whenever job arrives, I will put it in some sort of queue, and from the queue I will decide which job to take and give it to the CPU. Now in this same example, let I execute J4 first. Okay, I'll execute J4 first. I'll execute J4 here, which took 3 units of time. Then I execute J2, which took 8 units of time. Then I execute J3, which took 10 unit of time. Then at last I execute what is that, let J1, which was 15 unit of time. Now in this situation, let us calculate the average waiting time. So for that reason, for this approach, what is the waiting time for J1? Let's what is the calculate for J4? It will be 0, because before that there is no other process. For J2 the waiting time is 3. For J2 the waiting time is 3. For J3 the waiting time is 8 plus 3, 11. And for J1 the waiting time is 8 plus 3 plus 10, so 21. Now if you calculate average waiting time for it, it will give you 35 divided by 4, that will give you 8.75. Now you see how the average waiting time is affected drastically. In the first approach, the average waiting time was 17.75 unit, whereas in the second case the average time was 8.75 unit. So as a user, obviously I will choose second case. The reason is, here I am waiting less as compared to the first case. In the first case I am waiting much higher amount of time, that is 17.75 unit of time I am waiting on an average, but here I am waiting only 8.75 on an average. So therefore as a user I will prefer this, but now it is a system who takes decision that which one to choose. Okay, so and you might have noticed one thing, that in the second approach what we did is, out of all the jobs, the job with shorter amount of execution time, that I execute first. Means here out of J1, J2, J3, J4, the J4 takes less amount of time as compared to others, that is 3. So I have executed it first. So this is the shorter job which I executed first. Then out of other 3, 15, 8, 10, the next shorter job is J2, which I then executed. Then 10, then 15. The reason was, because the waiting time depends on all the jobs which are executed previously and how much time they are executed. So therefore when you have a longer job in the first slot, your waiting time will be much higher, whereas if you always execute the shorter jobs first, then your waiting time will be effectively reduced. For example, if I have a job of 1 unit of time, if I execute that before J4, then obviously J4 has again, before J2 if I execute, then J2 execution, waiting time will be 1. So this is the reason why we took this kind of sequence. So later on we will see in much more detail that this kind of approach, the first kind of approach is called FCFS, that is first come first serve, means whichever job came first it will be served first. And the second case is called shortest job first algorithm. But in this lecture my intention was not to introduce what is FCFS and what is JF. Here our objective is to see that why we choose the waiting time as one of the criteria and turnaround time is another criteria for choosing scheduling algorithms, and what are other algorithms, other criteria which we can take for selecting which algorithm is better for a particular situation. So now from these two examples, now we have seen that if we choose a particular way of scheduling, then it drastically affects the waiting time, and similarly it also affects the turnaround time. Therefore, in this case, the objective is to minimize the waiting time for this case. So similarly, there are other various criteria are also available which has to be considered before choosing one scheduling algorithm, and also we have to see that how do you really optimize those things. So let's see what are the other criterias, including the criteria which we already discussed. So these are the few criteria for scheduling algorithms. Okay, first one is CPU utilization. Already waiting time and turnaround time we discussed. Apart from these two, there are other three. One is CPU utilization. So whenever you select a scheduling algorithm, you have to keep it in mind that what is the CPU utilization during that algorithm. So CPU utilization means you try to keep the CPU busy as much as possible, so that it will give you the facility of multi-programming. Okay, but if you use some kind of algorithm where most of the time if CPU is idle, then that scheduling will not give you better efficiency. Okay, the next is throughput. So throughput means how many processes is completed per unit time. Okay, because if you select some algorithm where the CPU utilization is not good, that means most of the time it is idle. So when it is idle, it means throughput is less, isn't it? If throughput is more, that means many more processes are actually getting executed per unit time. That means that most of the time CPU is busy. Okay, and this is the turnaround time which I have seen, that it is a time needed from the time of submission of a process to the time of completion. That means when it gives the output, which I said, that is T0, TP minus T0 in our example. Similarly, waiting time is the total amount of time a process has been waiting in the ready queue. That means when I submit the job, that is I am submitting where? I am submitting in the ready queue. Okay, so and it gets scheduled in the CPU. So that is, let's at Ti it is scheduled in the CPU. That means it is going to the CPU at Ti, and at T0 I have submitted the job to the ready queue. So Ti minus T0 is the waiting time. And last one is the response time. So response time is the time between a process enters to the ready queue and it will be getting scheduled on the CPU for the first time. So you see here, for the first time means if it is a non-preemptive scheduling, we'll just see after some slides what is preemptive and non-preemptive scheduling algorithms. So response time mean in some algorithms we provide time to some processes. For example, there are 10 processes, and for some for all processes I assigned 2 nanoseconds for each. That means suppose P1 is a process which needs 10 nanoseconds for its execution to finish, but then I have set the timer as 2 nanoseconds. So what we do is, normally P1 gets executed in the CPU for 2 nanoseconds. Then we take out that process from the CPU and give P2 for execution. That means the next process. Again, after some time, again P1 will be given. It will be given in such a way that it will execute it for 2 nanoseconds, then again it will be going out of the CPU and stay in the ready queue. So it will go on moving like this unless and until it finishes all its 10 units. So in that case, response time is the time between when you submit the job in the ready queue and it is going to the CPU for its execution first time. So it is the time difference between it is a time between a process enters to the ready queue and gets scheduled by the CPU first time. Okay, so in some algorithm, in some systems also, this response time is also matters when you need your system to be much responsive for the user. So some examples we will see later on, that where this response time come to the picture. Okay. Now these are the optimizations we have to do. You see, as I told you, that CPU utilization, throughput, turnaround time, waiting time. So what do you think? What do you what optimization system must need to do for this CPU utilization? So obviously CPU utilizations should be more, isn't it? Throughput should be more, but turnaround time should be less, because it is the total time where a process is staying inside the system, means starting from its arrival to its completion. Okay. Similarly, waiting time should be minimum, as I discussed, and here response time will also be minimum, because if your response will take much more time, suppose you have given in one input and system is taking lot of time to give you response, so that system nobody prefer to use. So therefore response time should be minimum. So these are the things which need to be optimized in terms of CPU scheduling criteria. Okay. So it means we choose some scheduling algorithms where these things can be kept as much as, kept minimum as much as possible. Okay. And these two as much as maximum. Okay. As much as, whatever the algorithms you will be using, you just see that how CPU utilization, that means CPU utilization should be more and throughput should be more. Okay. Now there are few terms related to scheduling algorithms. So first term is the arrival time, which I said. So this is the time at which process get into the ready queue. Next will be the CPU burst time. So CPU burst time means it is the time required by a process to finish its execution within the CPU. That means the CPU time means exactly how much time it is executed inside the CPU. That is called CPU burst time. Now completion time, it is the time at which process completes. Then turnaround time is the time needed from the time of the submission to the time of completion. Then waiting time is total amount of time a process has been waiting in the ready queue. And last is the response time, where the time between a process enters to ready queue and gets scheduled on the CPU for the first time. So these are the few terms which will be requiring during some numericals of some algorithms. Okay, thank you. Thank you for watching my video. If you like the video, don't forget to hit the like button and share with your friends. Thank you.